This is part 3, solving for an unknown with algebra. The biggest stumbling block when using algebra in Physics 1 to solve for an unknown is when there's two equations and two unknowns. This takes patience, focus, and diligence. There's a lot of opportunities to make a mistake. So the basic strategy here with two equations is to solve for one of the two variables with one of the equations and plug in that expression into the other equation. So here's an example. It involves circular motion. Cars going around a bank curve. We have Fn and Fr. Those are two forces. And there's a second equation. One's from the x direction, one's from the y direction. Fn is the normal force. Fr is the frictional force. And you have to solve for both of them. If we want, we can plug in numbers. We have a calculator. We can plug in numbers for sine and cosine. We're going to leave them like that for a while. Plug in numbers later. Do whatever you want. So to start, we're going to solve the first equation for Fn. So here's the first equation. And we're going to solve this for Fn in terms of Fr. So to start, we want to get Fn. So we're going to put this on the other side by subtracting frictional force cosine 9 degrees from both sides. We now have this expression, and now to get Fn by itself, we just divide by sine 9 degrees. And now we have Fn. We have an expression for Fn. And we're going to take this expression, 8640 newtons minus Fr cosine 9 divided by sine 9, and stick it in right here to the second equation. You might have to go back and forth. Might have to play this one a few times just to keep track of all the stuff that's going on. So now we're going to do the substitution. Here's the second equation. And there's Fn. And we just solved for Fn with the first equation. And this is the expression we got. So we got this long, messy thing. We have to be careful. But now we have one equation and one unknown. So we're on our way. So we're going to take it slowly and carefully. We're going to distribute the cosine 9 degrees in here. So there's 8640 newtons cosine 9 right there, divided by sine 9. And then we have cosine squared here. Cosine 9 degrees squared, divided by sine 9 degrees times Fr. So now let's get numbers for each of these three terms. 12,000 is easy. We're going to plug in numbers for sine and cosine. The first term is 54,550 newtons. The second term is minus 6.236 Fr. And the third term is 0.156 Fr. So we're going to substitute these expressions into this equation. And we get this. So now we have two terms with an Fr. We can combine those. And we have 54,550 divided by 12,000. That's 42,550. And then we have two negatives here. And we put those together. And we get this. So now it's pretty easy to solve for Fr. We can add 6.392 Fr to both sides. Like this. And now we have this simple equation. Now we divide by 6.392. And we have Fr. Finally. 6656 newtons. About 6,700 newtons. Now we have an expression for Fn with Fr in it, so we can just plug in our Fr right here. 6656 right there. And then we can get Fn. Fn's about 13,200 newtons. But let's check. We got the answer, but a lot of opportunities to make mistakes. I'm always very happy when I plug it back in and it's right. So here's the first equation as presented. That was given to us, so we can stick in Fn and Fr here and see if it's true. See if Fn, which is 13,210 times sine 9 degrees, plus 6656 times cosine 9 degrees is 8640 newtons. So there are the two values we calculated. And this term is 2066, this term is 6574, and man, that is 8640. So very happy. Very happy. Now we gotta use the second equation, see if that works. Fn, this is the second equation, and we're gonna stick in the values, and we get the same thing. So we have the correct answer. And we probably should round them to 3 or maybe even 2, right? 13.2, 666, maybe it should be 670, 6670, 6700. So, of course, you can give this to a computer and they can solve it. You can plot it, there's a lot of different ways to solve it. But the purpose of the exercise is not to get the two forces as fast as you possibly can with whatever tools you have. It's to develop your skills as a problem solver. That's the goal. So if you go to the gym, you can say, I'm just going to use the fake weights. It's easier. Why would I work hard? Well, you're not going to develop. The harder you work, the more you develop. Simple as that. So to develop this quantitative literacy, that's the goal. Maintain focus. Have high standards for your performance. Be reliable. So to be able to carefully solve simultaneous equations, you have to keep track of a lot of stuff. It develops the prefrontal cortex. Determining optimal strategy. Maintaining an understanding of the problem in working memory. Working memory is very important to have. Keeping a lot of things in your head simultaneously. That's what this does. It develops that part of the brain. The parietal regions, numerical and spatial manipulations. And it will give you a reputation for being diligent, responsible, and focused, rather than sloppy, careless, and lackadaisical. Very important. Finally, thanks for doing your patriotic duty. It's hard. It's hard, but it's worth it. You don't rise to the occasion, you fall to the level of your training. That's Navy SEALs. Your performance is directly correlated with how hard you train. They understand this at the Navy SEALs. So be ready for any opportunity. Train hard. Be excellent. That's part 3.